Hello everyone, I am Prem Kumar. Welcome to Olympiad's Math Academy. This channel is completely for Olympiad's level. So from 6th to 12th standard who are aspiring for Olympiads, International Mathematics Olympiad, you can use this channel for your growth. Okay. So who need one-to-one interaction, online interaction classes, you can contact my number. So it will be available in the banner, right? YouTube banner, right? Okay. So today we are going to discuss the number theory problems. So before that, what I will do further, so I'm going to plan the all countries Olympiad problems. For example, Hungarian, New Zealand, you know, so Korea, and then America. So many countries Olympiad's problem I'm going to post coming days. So you can keep on watching this, and who are watching this channel, please subscribe it without any second thought, because this is completely step-by-step explanations with the proper sequence of videos will be there. Okay, you can keep on watching this video. Let's get started today. Number theory questions. Okay, so suppose that m and n are positive integers such that 238 is a factor of 7 power m plus 7 power n. Find the smallest value of m plus n. So first you have to understand 238 is there, no? 238, how to write? You can see, so it's a 2 into, so which one we can write? 7 into 17 we can write. That means 34 into 17 you can write, no? You can see 34 into 17 you can multiply. So you will get 238. Okay. So what is the actual questions? M and n are positive integer. 238 is a factor. You can use the congruence idea here. 238 is a factor of 7 power m plus 7 power n, right? It is congruent to, it's a factor means the remainder will be 0, modulo 238. It is same as what? It is congruent to 0 modulo 2 and modulo 7 modulo 17, right? You can take this one because if 238 is a factor means it should be a factor of 2, factor of 7, factor of 17, correct? Okay. So let me take 2. 7 power m plus 7 power n is congruent to 0 modulo 2 or not. First let me take 2 here. 2 or not. How you can check this one? You can see, so when you take 7, so when you divided by 2, modulo, what is the congruence? If you're not having any idea, please watch my channel. One short congruence video is there, right? Okay, 7 is divided by 2. The remainder is, what is the remainder? You can see it is 3 times 2 is 6. The remainder is 1, right? Clear? Okay, so if you rise 7 power something, you can rise, you will get 7 power, no, what will get? 1 power something will be 1 only, modulo 2, right? The same way you can see 7 power n you can write, 7 power n also positive integer, no, you can rise it, that is also 1 modulo 2. From these two things, let's take this as 1, This is 2. So 7 power m plus 7 power n is always congruent to 2 modulo 2, right? I am just adding that. So A congruent to B, and you can see B congruent to, you can see, you compare this. A congruent to B modulo m, okay? And then some other number, let's take C is congruent to B modulo m. So definitely you can see A plus C is congruent to B plus B, right? So B plus B is what? So 2B is modulo m, right? Understand? Okay. So the same idea here, 7 power m congruent to 1 modulo 2. The same way 7 power n is congruent to 1 modulo 2. You can add these two things. Adding 1 and 2, what will get? There is no changes, right? The 7 power m plus 7 power n is congruent to, again, 2 when you divide by 2, you will get remainder is 0. Modulo 2, right? So that means it's true for all positive integer. It's true for all mn belongs to positive integer. Clear? I hope everyone understand, right? Next, you can check the modulo 7. Let me take another page. 7 power m plus 7 power n is congruent to 0 modulo 7, you have to say. How to check this one? You know that 7 power 1 is congruent to modulo 7, it will be 0. When you take 7, divide by 7, you will get remainder 0, right? And then you can take 7 square, it is 49. When you divide by 7, the remainder is 0, right? The same way, if you rise for some positive integer, that is also remainder is 0, modulo 7. Therefore, some other positive integer, if you rise, that is also 0, modulo 7. Clear? Therefore, we can say 7 power m, 7 power n is congruent to 0 modulo 7 for all m n belongs to positive integer. I hope everyone understand, right? Okay. Just normal divisions only, right? Okay, let me check another one. Third one is what? 7 power n plus 7 power n is congruent to, we have to say, which one we have to say here? So we have to say this one, right? Yes, we have to start from here, no? Yes. So we have to take this one, modulo 17 you have to say, right? Okay. Okay, how to check this one quickly? It's modulo 17, right? So you have to 0, you have to say. So how to check this one? What mn will be satisfied, you have to check it, right? But when you have to write like this, 7 power n you can send to the right side, minus 7 power n modulo 17. Now you can multiply by 7 power n on both sides. So what will get? So some expression, some positive integer, if you multiply, there is no changes in the congruence, right? 7 power m minus n, you can, yes, you can see, yes, you can multiply 7 power n. So 7 power n is equal to minus 7 power n, right, into 7 power n, right? So better you can do one thing, you multiply 7 power minus n, then you will get right side will be minus 1, right? So minus n, here is minus n, modulo 17. Clear? Therefore, 7 power m minus n is congruent to, so base or same adding the power, n minus n will be 0. So that means 7 power 0 is minus 1. So that is 7 power 0 is 1, sorry, minus is there, therefore minus 1 modulo 17. I hope everyone understand, right? Okay. So we need the, let us take this one, we need m minus n, you can consider k. We need 7 least positive integer k such that it is congruent to minus 1 modulo 17. Which values of k is possible? You have to check it first. Okay. So how to do this? You can see, student. 7 power k is congruent to minus 1 modulo 17. You can see here 7. If you write 7, so you'll get okay, it's 0, but we need minus 1, right? 7 square you can take, it's a 49. So when you divided by 7 power 1 you can take, so modulo 17 you can take, this remainder will be 7 only, right? 7 square if you take, it's a 49. 7 into 7 will be 49. So when you divided by 17, so 49 when you divide by 17, 330, so 2 times you can take. 2 times 17 is 34. So here is 6, there is 9, it is 15, right? Check it once. 49, yes, 15 is your remainder. Clear? So I need to find out the k, the least positive integers value of k such that 7 power k is congruent to minus 1. Which values of k is possible? I am just finding out the k here. Okay. So then 7 cube you can take, so that means 15 is the remainder, you have to multiply 7, right? So what will get? Modulo 17 if you can do. So 15 into 7 is what? So 105, right? So let me take this one. Okay. So 105, right? So when you divided by modulo 17, so what is the least possible values of the remainder? So you can see 105, when you divide by 17, you can see, so 17 into 5 you can take, so 50, 85. So let us take 6, 6 into 60, 95. Let's take 7, 95 plus 17, it is more than that. That means 6 times will work. Okay, 6 times 17, how much it will be? 17 into 6 is what? 60, 102, right? 60, yes, correct, 102. But here 105 is there. So what is the remainder here? 3. Got it? 105, when you divide by 17, what is the remainder? 17 into 6 is how, what is that? 60, 42, that is 2, so 102. So the remainder will be 3. Then 7 power 4 if you take, 7 into 3, that is congruent to 21. When you take modulo 17, so when you 21, if you divide by 17, so you will get 4, right? Clear? Then 7 power 5 you can rise, that is 4 into whatever the remainder you are getting now, so multiply with 1 more 7, you will get 7 power 5. So 4 into 7 you can rise, so multiply 28, right? 28 when you divided by modulo 17, what is the remainder? So 2 times is not possible here, right? So 1 times only possible. So here is 3, here is 8, so 11, clear? 11 is the remainder, correct. So 7 power 6 you can take, so 11 into 7, it is 77. When you divided by modulo 17, 17, when you divide by 17, how many times is possible? 17 into 5 you can take 50, so 85 you will get, right? But it is not possible. Here 4 you can take. 17 into 4, how much it will be? 40, 28, 68 will come. 68, here is 2, there is 7, it is 9 is the remainder. Clear? Check it once. So 17 into 4, how much? 40 plus 28. So 68, 68, 2, that is 7, that is 77. Okay, that is 9. Yes, correct. 7 power 7 you can take. So 9 into 7, 63. Correct? 63, when you divided by 17, modulo 17, what is the possibilities there? Let me check here. 63 means 4 is not possible. That means 3 only possible. 17 into 3 is what? 30 is, it's 51. 51, here will be 9. There is 3. That will be 12. 12 is the remainder. Check it once. 30, it's 21, is 51. Yes, if I take, yes, correct. 12 is the remainder. Then when you take 7 power 8 you can take. So 12 into 7. 12 into 7 is what? 12 into 7 will be 70. It's 84, right? 84, right? Modulo 17. You can see which one is very nearest to the 84 will come. You can see, let us take 17, you can see. 17, if I take 5 times 17, how much it will be? 17 into 5, it is 50. 85 will get, right? The 7 power 8 is congruent to, is what? 84. That means, sorry, we did one mistake here. You can see how to rewrite this one. 7 power 8 is congruent to, when you 84 divided by 17, so you will get minus 1, because you can see when you multiply 5 times you will get 85. 17 into 5 is 85. So 85 is there, is congruent to modulo 17. You will get remainder is here 84, here 85. So the minus 1 is the remainder. Clear? So we need that only, right? So which values of k you can choose, that you will get minus 1, right? We need that only, no? So 8 only possible. Here is 8, k is what? So m minus n you can choose here. So 8 is equal to m minus n, right? So from this, m how to write? 8 plus n. So we need the minimum value of m plus n, which is the smallest value of n you have to choose. Then only you can, sum will be the minimum, right? The smallest value of n, you can take 1, right? That is the first natural number, right? The positive number, right? Okay. So then m will be 9, correct? So you just put here 8 plus 1 is 9. The total, the minimum value of m plus n is equal to n. M here is what? 9. N is 1. It is 10 is your answer. I hope everyone understand. So we'll continue the next problem. You can see that for any real number x, the greatest integer function is less than or equal to x. Find the value of the greatest integer function of the smallest x. Satisfies the equation, right? Greatest integer function of x square minus greatest integer function of whole square is equal to 100. Then how to solve these questions? You know that greatest integer functions, you know that, right? The greatest integer function is a function from real number to integers, right? Suppose if I take the greatest integer function of 2.5, it will be 2. If I take minus 2.5, the greatest integer will be minus 3. So that is the greatest less than or equal to minus 2.5. That is the greatest integer, right? If you not have any idea of greatest integer functions and fractional part function, you can watch my one shot greatest integer function and fractional part functions video. Okay. Let us take the greatest integer function. Let us take n. Okay, n here is the integer, right? Then how to rewrite this question? The greatest integer function of x square, so minus n square equal to 100. So therefore, the greatest integers x square, how to write? 100 plus n square. This is first observation. Okay. But we know that if a greatest integer function is equal to n means x will be fallen n to n plus 1. You already know that, right? If you're not having idea, you can watch that video. Okay. Now we need x square. Squaring on that, x square is less than n plus 1 whole square. So definitely the greatest integer of x square should be n plus 1 whole square, right? Clear? Understand? So what is the greatest integer function of x square? 100 plus n square should be less than n plus 1 whole square. Let me take another page. 100 plus n square is less than n plus 1 whole square. Clear? You can simplify this. 100 plus n square is less than a plus b whole square expansion plus 2n. So you can send everything one side. N square minus 1 minus 2n is less than 0. So this will be cancelled. So 100 minus 1 minus 2n is less than 0. 99 minus 2n is less than 0. 99 is less than 2n. So 99 by 2 is less than n. This is 49.5. Correct? So therefore we need n is more than 99.5. You can see here, this is your 49, 49.5 you can take, this is 50, right? This is 49, right? So if we need more than 49.5 is required, means the n you can choose the least, right? The smallest, the greatest integers here is what? 50 only is possible, right? Okay. So n here is 50. Then what they're asking actually, the smallest x satisfying this equations, right? If you consider n is 50, but you know that the greatest integer function of x square is what? N square plus 100, right? If you substituted here n, 50 whole square plus 100. So that means 2500 plus 100, that will be, that 2600. The greatest integer function of x square is 2600. That means x square will be fall in 2600 to 2601. You already know the definition of the greatest integer function of x, right? You know that greatest integer function is equal to n means x will be fall from n to n plus 1. Okay. So then what is the suitable x value possible here? You can see x will be square root of, so you can include this one, no? This is only possible, x equal to square root of 2600 only possible, right? You can see x is square root of 2600. So square root of 2600, that is 50 point something will come, right? 50 point something, right? So that means the greatest integer functions of 50 point something will be 50.9 something. If you take 50.9, so this will be 50 only is coming. Now you have to verify this. The greatest integer function of x square. X square already know that 2600. X square is 2600 plus, oh sorry, okay, what is that? 2600 minus the greatest integer function of x is what? 50, clear, whole square, right? So you can see the greatest integer function of 2600 is 2600 minus the 50 square is 2500. So this will be 100, satisfied. So therefore the suitable x here is what? Square root of 2600, that is 50.9. So we need the greatest integer function of x, that is 50. Okay. Therefore here is the suitable n here is what? 50. Understand? So n here is the greatest integer function of x. I hope everyone understand. So if you like this video, please subscribe my channel. So coming days I will post you different global Olympiads level questions. Okay. Thank you everyone.